How do friends? So today I'd like to talk a little bit about SQL injection. So SQL injection, it's a web application attack specifically targeting web applications that have a database backend. Now in 2017, OWASP, which is the Open Web Application Security Project, they released a list of the top 10 most serious vulnerabilities for web applications. And right there at spot number 1 was SQL Server Injection, or SQL Injection rather. Now moving on to 2021, this list was actually updated and SQL Injection moved down from 1 to 3, but that doesn't mean that it's any less serious. In fact, I'd say it's just as devastating now and as simple to perform as it ever was. The major difference is that development has moved on a little bit since then, and frameworks such as .NET Core and using Entity Framework make it by standard a lot harder to introduce this vulnerability into your code without actually thinking about it. As before with, say, OLEDB, you would have to make thought to make sure that everything was parameterized coming in, which I will discuss in a little bit detail later on. Now, as this talk progresses, what I'd like to do is show you some live hacks, both automated and manual. And hopefully, as a web application developer or someone with a passing interest in security, or even someone working towards a certificate such as CISSP or Certified Ethical Hacking, that this will help you and at least give you an insight as to how devastating and serious this attack type is and how to mitigate it in the future. So where I'd like to start really is with the different SQL attack types. So we'll start with the authorization bypass. So on a normal website that has a username and password login box, you type username and you type your password in. In the username field, for example, I type my name Joshua and a password, let's say password 1. Now, when that goes back to the server side, it's going to effectively perform a database query and say something like select X from users where username equals Joshua and password equals password 1. So obviously my username is Joshua and my password is password 1, so that will return a row and it would effectively return a value. So there the application now knows to log me in. Obviously in a normal environment this would be hashed, so it would perform the hash first on the password then compile that to the database. What a SQL authorization bypass attack allows you to do is to inject a little bit of SQL into the username or password box so that it effectively bypasses that check. With SQL, you could, for example, type select star from users where ID equals 1, and that would return just the first row in the database where the ID equals 1. However, if I was to say select star from users where ID equals 1 or 1 equals 1, 1 always equals 1, so that's going to return every single row in the database, and that's known as tautology. So using that and with that little bit of knowledge in mind, I'm going to now show you this type of attack in action. So now I'd like to show you an example of exactly how we would bypass authentication using a SQL injection bypass injection. So here we have testasp.vulnerweb.com. It's a website that's deliberately been designed to be vulnerable to SQL injection. So we just pop over to the login page, presented with the username and password field. So if I type Joshua in there, or some variation of it, and the password, and click login, it will say invalid login. So what actually happened there? Well, the username Joshua and the password of password was pushed to the web application server, and the code then ran the SQL statement on the SQL box, which was effectively something along the lines of select X from users where the username equals Joshua and password equals password. So if a row exists with the username Joshua and the password, then it will actually return a row. So to the front end, it knows that that represents a valid login. Likewise, if a invalid password was put in, nothing would be returned. So what can we do to try and trick that? Well, first of all, I'd like to take us over to SQL. So here we have SQL Server, Adventure Works database, and we've got a number of tables here. So person.person, person.person phone, and person.password. Between the three of those tables, we'll be able to get the information that we need. So just bear with me a minute while I type some SQL. So there we go. This SQL here basically joins the person table to the email table and to the password table. And what we've returned is the first name of the user, Ken, last name Sanchez, a password hash and a password salt. So before, when I said the example of it, would run the SQL saying where username, email address equals whatever it was, the username, and the password equals password. In some websites, if the correct security precautions have not been taken, then the password will be stored in plain text. But here, we have a password hash and a password salt. So that basically means that it's a little bit harder, or potentially a lot harder, to decrypt that password and find out what it originally was. So what actually happens then? Let's pretend that this was the user that was logging into the website, and the SQL that would be performed and run against it would be something like this. So it would say email address equals and password hash equals. So obviously running that, it returns a row. Now, if I was to change that password hash because the password provided was wrong, you'll notice that no rows are returned. However, what I could do is add or 1 equals 1, and then if I run that, it returns every single user in the database. So what it's actually saying here is where the email address is equal to that, or the password is equal to that, or 1 equals 1. 1 always equals 1. So everything's going to return true and return. So that's what we're going to attempt to do with the user login box. And in the username of Joshua, we'll leave that as Joshua, put a single quote in there, and go or 1 equals 1. Now, flicking back quickly to SQL, what I could do here is put 2 little dashes in, and that comments out that code. So if I was to run that again, nothing's returned. So by putting this here, it means that any SQL that's constructed after that will not be run and compiled. So if we now hit the login box, you now see that it says log out Joshua or 1 equals 1. So obviously there's no user in the database called that. what's happened here is I've successfully bypassed authentication and managed to log in with an account that doesn't even exist. And that's a basic example really of SQL authentication bypass. So moving on to the next hack now. So let's briefly talk about information disclosure. So information disclosure is another type of SQL injection attack where the main aim of the attacker is to exfiltrate as much data as possible from your database server, stuff that should normally be hidden from an end user, potentially personally identifiable information, stuff that could be embarrassing if you were to have to announce you lost it, for example, a GDPR breach, or even worse, or just as worse really, they could dump your username and passwords table and then attempt to crack the passwords by brute force or using a rainbow table, so that you had full access to log in as other users, potentially even administrative accounts, to cause further damage. So again, I'm going to use the vulnerweb website to show an example of this. I will later down on the line on this video perform most of the attacks that you've seen here and some more, including getting shell access on a automated tool, SQL map, to give you an idea of how easy it is to use a tool to do this. So without any further ado, moving on. So here we are again, back on the vulnerweb website. This time it's the test PHP version of that. So usually when you're dealing with PHP, you kind of expect the database in the back end to be MySQL. And if you're dealing with ASP or .NET as before, you kind of expect the database to be Microsoft SQL Server. However, this isn't a hard and fast rule, and there is ways of sniffing out this information. This is usually done by a method of attack called blind attacking. And you'll pass in the commands that are specific to that type of database engine. So for example, with SQL Server, you pass in wait for delay 10, and if the SQL command takes 10 seconds to come back, then you know that you've got a Microsoft SQL Server. To that end though, I'll speak about that later on in this talk, and I don't want to go into too much information here. So going back to the website, what have we got going on? If we go to categories, and into the categories, you see here that we've got category equals 1. It's not got that many bits and pieces in there. So what we do is when you find a query string parameter on a website, a good thing to do, if it's a site that you're allowed to hack, is to just stick in a single quote and hit enter. And if that returns a SQL error as it has here, that's a good indication that you found a parameter that's vulnerable to SQL attack. So once you've sussed out that you've got a parameter that's open to SQL Server injection, SQL injection, what do you do with it? This is something. So as we spoke before on tautology, pass in our 1 equals 1 there and hit enter, and it's returned every single category, and there is a fair few more items on that list. So now we know for 100% certain that we are dealing with a parameter that's pervious to SQL injection. So let's use that parameter to start exfiltrating data. Now if you go to sqlmap.org and just download the zip file, extract this to anywhere on your C drive, or if you're on Linux, anywhere into your file system, you can then run that using Python. You may need to install the Python compiler if you haven't already got it. So to do that, because I've already installed it, I'm just going to open up command prompt. Now I installed this into my root of C directory, so if we just navigate to there, so cd and then cd into the SQL map folder, and first thing that the SQL map.py Python script expects is the -u parameter. This is the URL of the website, including the parameter that you've sussed out is vulnerable to SQL injection. If we just copy that and it wants to be in double quotes and pasted in there. Let's hit enter, wait a couple of seconds, and we can straight up see that the database backend management system is MySQL. It's running Linux Ubuntu, PHP and the version number, and Nginx web server version number, and MySQL and the version number. So a useful thing you can do here, although it's out of scope of this talk really, is you can go to Google and search vulnerability databases for, let's say, MySQL version 5.1 and find out if any backdoors exist or any sort of vulnerabilities that you can exploit in order to further get onto this system. Okay, so the next thing we can do is SQL map, and that we'd probably want to do is to find out what databases exist on the server. So we'll pass in the DBS switch. So what that allows you to do is get a list of the databases on the server, and we can see here we've got ACUArt and information schema. Information schema is the default database that exists in MySQL, and it just has loads of tables in there that are really used for describing the structure of the database and used for system internal functions. I'm not really interested in that right now, although it is a powerful tool to have access to. And I'd advise, if you don't know much about it, to actually Google that and look into what you can do with the system tables in MySQL or SQL Server, etc. So the next thing I want to do is to get a list of the tables in the database. So this time I'm going to pass in the -d command. Well, actually no, minus tables, and the -d command, and pass in the name of the database server, which is ACUArt. So there you can see the database ACUArt has 8 tables in it. It's got a users table, products, artists, cat eggs, which is the categories. But right now I'm interested in exfiltrating the users database. Potentially it'll allow us to hack into the website. So in order to do that, again, we just need to pass in a simple command, which is -d for the dump. Pass in the site name, ACUArt, and we want -t for the table to tell it, which is users, and then we can dump it to a file. Boom, off it goes, fetching columns for table, fetching entries for table. Oh, it's recognised possible password hashes. Do I want to store them into a temporary file? Normally maybe you would, because you might want to attempt to crack them at a later date, but in this instance I'm not bothered. You can actually also, while you're running this, if you have a passwords file, run a real-time brute force attack on the files, on the hashes. I'm not interested in doing that now either, because it'll take too long, and plus I already know that this database doesn't have hashed passwords at all. So no. So we can see a command version of the table, and it's also logged it to this table here. So if I go to that site directory and open up the dump folder, we have a users.csv file. And if I open that up, we have the column names and then the data. So the first thing, CC, is the user's credit card number in this example. The next thing is the car ID, which is an internal ID that links the user to the current car that they're running. The name, Larambaras. Password, which as you can see is test. Their email address, email@email.com. Phone number, and the username test as well, and an address. So this information that we just exfiltrated now, we now know that the user is called test and the password is called test. So we can potentially attempt to log in as that user. So if I go to your car and log in, type in test and password of test that we got from our exfiltration. It threw a temporary error, how nice. But we'll try again. There we go. So we've actually logged in as that user with information that we shouldn't have been able to have. So that kind of covers information disclosure, and we can now move on to the next topic. So compromised data integrity, what I said. So obviously a database runs a website. Let's say that your website is a shop and you sell bunnies. Now, what would happen if I was to use SQL Injection to change all of the descriptions of the bunnies to something silly like evil hopping beast? Well, as a website owner, it would be embarrassing, and as an end user actually wanting to buy a bunny rabbit, I'd look at the website and think it was a fake, or they were just having a joke, and I'd lose any faith and I wouldn't buy anything. Furthermore, I could obviously also delete all the sales record history. I could delete the products that they're actually selling. This is the premise of data integrity, really. You want your data on your SQL server to be unalterable by anyone other than yourself or authorized users. So now I'm going to show you an example of how a simple parameter exploit can be used to update data on a database server and effectively change that so as end users can see the changed data. So I couldn't actually find anything on the internet that allowed me to demonstrate compromised data integrity, specifically either issuing update commands or insert commands, etc. So I had to write a little quick and dirty test application that allowed me to demonstrate that. This uses stacked queries. Stacked query is basically where the first command is run. So in this example here we've got id equals 1, which is returning a single item with the ID of 1, and then you'd run the update command after that. So effectively running 2 commands. So what I want to show you here is obviously it is vulnerable to SQL injection. So we can do the usual or1 equals 1, which returns everything. And if we flick to the database for that, the table is production.location. Now, because I've previously discussed on the last vulnerability how to enumerate a database server, get the name of the table and the name of the databases, I'm not going to actually do that this time. I'm just going to assume that we know what the database and table is called. So what should we do? Well, SQL command again, and let's get SQL map up. So we'll just get a command prompt and cd off to the root of C and cd to SQL map again, and the URL parameter, which is the question mark equals 1 part, because obviously it needs to include the parameter that's variable. But this time the only difference is I'm going to pass in this command switch here, which is SQL shell. Now a SQL shell allows us to run ad hoc SQL against the database server, and in this instance what we're going to do is run an update command. So update production.location And then we're going to set the name column to be name plus ha 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 ha, I hacked you, and then run that. So now if I reload the website, you can see that we've actually defaced the website and updated everything to ha ha ha, I hacked you. Now another thing that we can do is, let's pick a table like, let's go with what I'm looking for is something that hasn't got any database integrity, so I can actually delete from it. Let's go with the error log table. Let's see if there's anything in there. Wait a little bit of time, and there's nothing in there, so we can't use that. Cool. So in the database log, we've got a load of data in there. So what we can now do is we can delete from dbo.database log. And now if we run that query, we can see that it's empty. So just using a simple SQL injection parameter, we've managed to effectively delete data, and that could lose months, weeks, years of work and posts for a user if correct backup was not done. So that covers database integrity, or specifically the file integrity and database entry integrity. So we can now move on to the next item. So, remote code execution. Remote code execution is probably my favourite form of SQL injection attack. It's exactly as it sounds. It allows you to remotely run code of your choosing on the server. This can be done by a number of means. For example, within PHP-based servers, you can use the into-out file command with SQL. So let's say select PHP echo hello world into out file, and then you pass in the string of the path on the server we want it to save. So ideally within the website folder, for example, var www.html/website name. Then once that file has been run by the SQL server, e.g. MySQL here, it will create that file in that path. You can navigate on the browser to the / path on there, and it will show you that hello world response. Obviously this can get a little bit more fruity. Let's say if you were to put in a reverse web shell PHP command in there, allowing you to pass in get parameters in the query string, and allowing you to, for example, put in something like ls to return a list of all of the files in the current directory you're in, or much worse really, sky's the limit, or as far as the account's locked down to that is running under. Another thing you could potentially do as well is to use the load file function within SQL, or MySQL specifically, which would allow you to, for example, pull back the contents of the etc. passwd file, and get a list of the passwords and, well, user accounts really. Within MS SQL Server, you could do the XP command shell, which you could potentially, even if it's not enabled, you can enable that via a SQL injection. And then once you've got XP command shell, you can issue sort of system info, for example, commands to get information on the server it's running. But for this example here, or as I'm going to demonstrate shortly, I'm going to use SQL map to automate a lot of this for me. The SQL map remote exploitations, there's a few options there. I could do -os shell, which gives me an operating system shell that uploads a basic shell file onto the server and then returns me a reverse shell to allow me to type in my commands. And then there's os-pwn pwn, and that either creates the same, you can do a shell, or it works hand in hand with Metasploit and creates a Metasploitable shell, which you can do some pretty cool things on. For example, switch the webcam on, take photographs of the person sat at that computer, or even play sound recordings on the destination machine, as well as issue your standard Linux or Windows commands, as the case may be. So without any further ado, let's move on and take a look at some of these exploits. So here we are in Kali Linux, and I've installed DVWA, which is a web application, damn vulnerable web application to be precise. It's a web application that's been specifically designed to allow you to test your penetration testing skills, stroke hacking skills, and it's got a variety of different skill levels, starting at low and going all the way up to impossible, which theoretically should be impossible, as the developers patch every known vulnerability soon or as when they find them. So if you can hack into it on the impossible level, pretty good kudos to you. So anyway, let me give you a quick demo. So if we fire up Firefox and pop over to the website I've installed, which is on localhost, and just log in. So the first thing to check is the security level. We need to make sure it's at low because it defaults to impossible. Otherwise our injection hacks won't work. And we'll pop over to the SQL Injection tab here, or button. So pop in a user ID and we get a user back. Let's pop in a user ID and go R1 equals 1 and submit that, and it returns all of the users. So obviously we now know we're dealing with a valid SQL injection form field. So remote code execution. So what we do, let's start with something quite basic. So what I'm going to do here is, I know that there's two columns, first name and surname. So any selections, I need to include two columns in that. So the first thing I'm going to do is end the ID, so it binds nothing, and then I'm going to do a union command, which means basically pin on another select afterwards. So I know that there's two columns, so what I'm going to do is select one, just for the sake of a field to be filled, and then we're going to go with load underscore file. And then in there we want to pull back the etc/file. So what that's going to do is it's going to execute a command against the MySQL database and call load file, and then we're asking for the passwords file from the set directory. So if I run that off, there you go, you see that we've remotely executed a file load. So doing this, we could pretty much read anything we knew the directory location of in Linux. Here we've got a list of all of the usernames on the system. So that's just the tip of the iceberg, really. What we can do now is take this to the next level. SQL, or MySQL specifically, has the concept of a function called into/out file, which allows us to pipe the results of the SQL selects that we've done into a file. And what we're going to do here is create a reverse web shell, or just a PHP web shell that takes a command and runs against the server. But in order to do that, we do actually need to know the file system structure. So the best way of doing that usually is if a web developer's been a bit remiss, they'll leave a PHP info file in the server. So let's have a look. So if I go to, strip this off. and type in phpinfo.php. So if you don't have access to this file, then you're either going to have to brute force it or try and get an error, a PHP error somewhere, which will include the location of the website installation path in the error usually. So here we have PHP info. It contains a whole host of information about the version of PHP running in the environmental variables. What we're really interested in though is the Apache environment area here. And if you notice, under document root we've got var dub HTML, and the actual script itself sits under same location but then dvwa. So we know that the path to this web application is var/www/html/dvwa. So we can now use that information to our own nefarious purposes, like so. So if we pop back into the SQL injection file, and just like before, we're going to do a union, and then we're going to go select one, that, so question mark system, so I've done this before, and I'll just paste that in there. So what you've got here is select system $_request, and it takes a command parameter into out file, and then we've got var HTML/dvwa, and then we'll call it webshell.php. So now if I run that, it returns an error, but that's because it's expecting a SQL result to come back, but this doesn't return anything. The SQL result must be type. So if I was to run that again now, it says the file already exists. So now we know that we've created a file into the file system. So if I strip everything off at the end here and go to webshell.php question mark cmd, which is a parameter, equals, and then let's get the network adapter bindings, so ifconfig, and run that. So I must have called it something else. Webshell.php. So what have I done dodgy here? So just need to get rid of that little hash at the end of that pattern. So as I was saying before, if you can cause the application to throw a PHP error, you can see here that it's posted in the path. So that's one way of finding it, another way of finding it. But obviously it's throwing this error here because we didn't provide it a command. So I'm going to go and tell it to run ifconfig. Question mark command equals ifconfig. And there you see we've got the dump of the network adapters, the addresses and local host addresses that it's sat on. Obviously we could do an ls, and that returns a list of all of the files that are in the directory that we're currently in. Obviously any Linux command will work here. You could ping another server, for example, but that kind of really covers sort of what you can do from here. You could craft a little bit better of a reverse web shell than this, and post it into the out file, or even just modify a page and make it look like a legitimate page that posts results back to your own server. Anything's possible, really. You just write into a file and stick it on the server, and then the web server will parse that. It could even be a reverse shell that you listen to, for example, with MSF Venom, but that's kind of out of scope for here. So the next thing I want to do then is to show you how to do this type of exploit using SQL map. So if we first of all go to the website again, and we're going to pop to the SQL injection page. And because this uses cookies, we're going to need to get the cookie to pass that into SQL map. So if we go into console and type in document.cookie, and copy that out, because we will need that. And let's get a command prompt up. So SQL map minus EU, and then we need to get the path to the website. And then tell it to use the cookie that we've logged in with that's been created. So and then let's copy that cookie out. I'm not sure how it's gone. Okay. So the next thing we're going to do is we're going to tell it to os-shell. And now we wait. So looks like the back end is MySQL. Do we want to test for anything else? No, because we know it is. Do we want to? Yes. So it does all tests. And waits in time, and hopefully we should. So get parameter is vulnerable. Do you want to keep testing the others? No, because there is no others. Okay, so what have we got going on here? It's saying what web application language is it running on? So default for PHP. And then if you look at the text here, it's trying to upload the file to var.dub, failed. Looks like it's not failed, and then it successfully uploaded it to the HTML VWA file there. So what we've got now is an OS shell, and we've just bust in, and we can now run commands as if we were on the server. This gets a little bit more interesting now because we can use the OS pwn command now, and I shall show you an example of doing that. So this time we're going to do pretty much exactly the same thing as we did last time, but this time you'll notice that I'm using the option -os -pawn, well, pwn pwn, and that gives us a slightly different option this time in that we're going to create a metasploit shell. So same as before, default PHP, it's uploaded the file to the server. We're going to do reverse TCP connection, use the local host and the default part, and option 2, because we want the interpreter shell. It's a little bit flaky and it can take a bit of time sometimes or fail, but if you're persistent with it, you usually get a connection. But it does take a little bit of time. So if we just wait a little bit. And we want a 32-bit system. So we successfully uploaded the shellcode exec file, and we're now firing up the Metasploit framework CLI. And here we go. So it's used the reverse TCP payload, and it's created as a shell, and there we go, we have an interpreter shell. So obviously we can do the usual type of stuff that you can with a shell, but with it being the interpreter shell, we've got a little bit more functionality here. So if I do a help, you see you've got a whole host of commands that you can do. Some of them are quite fun. For example, you can switch on a microphone, listen to whatever's going on in the same room as the web server's hosted on. Switch on the webcam, take pictures with the webcam. You can create a shell, list running processes, etc. on the server, or with it being a Metasploit shell, you can start running exploits against the machine. So I hope that gives you a good idea of how powerful remote code execution is, and that we can basically root a machine quite quickly and get command line access just via a simple SQL injection vulnerability. So hopefully now you've seen all that, it gives you a good idea of what's possible using SQL injection. As you can see, or have seen, it's pretty serious exploit to have available for an attacker on your machine. Quite easy to get root access, quite easy to basically compromise your entire web server with this vulnerability type. So in the future I'll be posting more videos going into a little bit more depth of the specific types of attacks that you can have, explain a bit more detail about the difference between different SQL attack types, such as a blind attack versus just a normal SQL injection attack, and other good bits and pieces like that. So moving forwards, if you want to investigate more into this, I'd recommend that you search for on Google SQL injection cheat sheets, and possibly look into Google Docking to allow you to be able to search for vulnerable websites on the internet just by using Google. So thanks for watching. I hope you found something at least vaguely interesting in this, and if you liked it, feel free to subscribe and watch some more content that I'll deliver in the future. Thank you, have a lovely day.